Hi, this is Tom, and so I'm on the Desmos website here and have fiddled around with it a little bit. It's pretty impressive. Desmos is just an amazing uh, website, best online screen calculator there is, in my opinion. And I've never worked with it with sequences before, so this is sort of new. Well, the one that I picked to experiment with is number 4. Uh, so let's go change this function to be into the 4th. Okay, into the 4th divided by 3 to the n. Oop, 3 to the n. 3 with an exponent of n. There we go. And so it says the first question is, does the sequence converge or diverge? Well, I'm going to zoom out here, and this sequence does converge. It converges to 0, and know this from calculus, from properties that an exponential will overwhelm any polynomial. But we can also see it visually here. Again, let's play with S. Goes down. Oh, okay, all right. What do we think we're centering on? Okay, okay. So if we say S is 0, there we go. Okay, all right. S is the presumed limit. All right. Well, S equals 0.25. All right. It says, let's change that to 0.25 now that I know what that is. Okay, so it's centering. S is the presumed point of convergence, and it says start with it at 0.25. And if we start with epsilon equals 1, well, we've got, let's see. According to this, we have convergence in that we are in the epsilon strip. But if I make epsilon less than the 0.25, like 0.125, then we see, nope, that's not going to work. That's going to fail. Okay, well, we know, let's see, it told me to use S. All right, so we're going to go to 0, which would be the second choice, or the obvious choice for this thing. Certainly appears to converge to 0. And with epsilon equals 1 1/4, well, here's the only thing that I noticed in fiddling with this. Love it in just about every way except these dots are too big. In fact, if we made epsilon equal to half of that, 0.05, we say, oh, well, let's see. Gee, it looks like the dots are outside the epsilon strip. So these dots are auto-scaled somehow in the program, and they're just a little bit big for my taste. I did go to the tools, and you can change the colors of the dots and things like under the wrench here. You can change the colors of the dots and whether they're opened or closed, but the size of the dots we're stuck with. Okay, well, let's get to the questions. Does it converge or diverge? Clearly it converges to 0. Set S equal to S. Okay, so we did finally figured out what S1 and S2 are. They are the presumed convergence point values. And then with epsilon, okay, so let's make epsilon really small, like 0.01, and zoom in, and the dots seem to be, again, we have an issue because of the dot size, but at some point, if I zoom in, I go, oh yeah, they are certainly bound within epsilon there, okay? So let's get to the possible definitions here. Possible definition, S is a limit of a sequence when infinitely many points on the graph are covered by any epsilon strip as long as it's centered at S. Okay. Well, that is certainly, yes, I see that as a valid definition of convergence. If we look at definition 2, let's zoom back out. Hope you're not getting seasick here or motion sick. Okay, definition 2, we have a finite number of the points are outside the epsilon strip. If a finite number of them are outside, S is a limit when only finitely many points are not covered by any epsilon strip. Now I've looked at these two definitions, and I do not see a counterexample where one would be satisfied and the other would not. So I see these as equivalent definitions. We'll see if somebody spots something that I'm missing. Okay, well, it's a great little utility here, and I'm not going to ramble on any more about this. So I'll stop here, and I'll look forward to seeing what you other folks put up, and probably be better than mine. Smoother, no doubt. All right, well, thanks for your attention.